Solo para ver si se te ve bien. Nada, no hace falta que hagas nada. Solo para ver qué te pillamos. Yo creo que sí. Te vas a mover así, ¿no? Por aquí.
Sí, no sé si, bueno, no,
Puedes hacer lo que quieras.
ahí lo ves
Una
también.
montañeta.
Ahí se reconsulta los precios.
que nos van a dar unos detalles bastante interesantes sobre lo que hacen. Y luego va a hablar Iván, un viejo conocido del Meetup, que está por ahí, y que nos explicará también cómo usa Rust en su empresa también. Bueno, en lo que tú haces, ¿no?
Es un binding para el trabajo, pero no vaya.
Perfecto, ahí es. Y con esto, pues, vamos directamente a la primera charla. Por favor, un aplauso para Herme.
They told me to do this earlier, but I forgot.
Está apagado.
Okay, so okay, now can you hear us, everyone?
Yeah.
Wow, we are a lot of people here. Thank you all for coming. Thank you to the Barcelona Rust community for having me also. As they told you, I'm Herme García. I'm a software engineer at Nuclia, and I'm currently working in our Rust code base. First of all, I would like to tell you a bit what is Nuclia. We are a startup based in Manresa, as you have heard, although our team is highly distributed. We have teammates from Madrid, Barcelona, and the US also. And our purpose is to get the answers you want to get the answers to the questions you always wanted to ask your unstructured data. Okay? It's something like this, but instead of intimidation, we use actual immunity. Okay? So, telling you about every detail that goes on at Nuclia to be able to extract knowledge from your unstructured data would probably require several talks from lots of colleagues of mine, and now in this talk I cannot get all of them. So I encourage you to visit our incredible website, which is nuclia.com. There you will find lots of resources and you will be able to find a lot of details about it. Also, our CTO, Ramon, which is here, has great talks across YouTube explaining some details about how we do what we do. Okay, I have been telling you a lot about what I'm not going to talk about. Now I will tell you what I'm actually going to talk about. And in this case is that we use Nuclia. At Nuclia we use Rust to extract knowledge, to retrieve efficiently the knowledge we extract from unstructured data. These tools are called search indexes, and we use them. And in this talk, I would like to tell you about one of them in particular, which is our semantic search index. Okay. Before doing that, let's do a quick overview about what semantic search is. If we all think about how our interactions go with a search engine, they all start with a query. In the case of Nuclia, this query is in textual form. You type your query, and then if you are using a text search index, it will extract some keywords from it and use a scoring mechanism to tell you what the best answer to that query is. An example of this is this one. We are asking our favorite text search engine who Eudal is. Upon getting such query, the index will go through the data, and it will find, in this example, 3 candidates. The first one is telling the index that basically Eudal is arriving late. We see that in this query, 2 keywords are matching with the query. The next candidate is saying that Eudal is the CEO of Nuclia. Again, 2 matches. The last one is saying who is knocking at this hour. Again, 2 matches, right? So the index now the search engine has found a problem here. We could use different scoring mechanisms like BN25 or other things to try to infer which of these candidates is the best one, but in general they offer sort with these kinds of query. I'm sure if I were to ask each one of you which is the best candidate here, the answer will be unanimous, right? It's the middle one. We are able to do so because we can infer meaning and context from the query and from the data. This is what semantic search is trying to achieve. And this is what we as Nuclia want to offer our users. Obviously, how we do this is another problem, because it's not just like we can send our laptops to high school and they will end up inferring context and meaning from things. That's not the approach, an approach we can take. Lucky for us, the incredibly bright people that is working on AI at Nuclia know how to express this problem in terms our glorified Turing machines can understand. And in here, I want to show you an overview through this schema. I'm sorry, because I can only express the technology they use as AI magic. But basically, the idea goes, in the Nuclia pipeline, you will send your unstructured data. It will be processed through some plug AI magic, and it will infer knowledge from that unstructured data. That knowledge, some of that knowledge is a similarity function and a set of embeddings. What are those things? Let's see. An embedding is the result of encoding data into a vector. Think of it as RGB, but for complex data. Then, a similarity function is a mathematical function that, like the ones we are used to, that is used to compare these embeddings. It tells you how similar one is with the other. Turns out that using these two concepts, we need less than 20 lines of Rust to write an approach for semantic search. In this case, our search parameters are just the dataset, which is now a set of embeddings, a similarity function, and if everything goes all right, our query is in textual form. But we can use the same AI magic at search time to transform the query into an embedding. Using those elements, we can traverse through our database, our dataset, computing the similarity per embedding. We just need to take the maximum. This is really simple algorithm, and it's also a really bad approach, because this approach does not scale. Not only because we expect the number of the dataset to be huge, it's also because AI embeddings are notoriously famous for having extremely high dimensions. So computing the similarity function, which is here done at line 11, turns out to be an extremely high cost. We need to avoid doing it as much as possible. To do so, what we did is first focus on the dataset.
Your microphone. Take it a bit down.
Sorry. Can you hear me now?
Yeah.
Oh, I've been talking without you hearing me. I said all the secrets from Nuclia. So the first thing we are going to do is take a look at our dataset. We are now storing all the embeddings in a list, but I'm sure there is a better data structure that is optimized for search in this kind of a scenario. Especially if we take into account that maybe the dataset is not going to change. It's going to remain the same in every query. So, turns out our assumptions are right, and what we can build is a graph with those embeddings. We just need, we will use in the graph nodes our embeddings, and the weight of the edge between source and target is going to be the similarity between them. Doing this, we have transformed what was an iteration through all the embeddings to a graph traversal that will end as soon as the similarity function stops to increase. This way, we can avoid lots of comparisons. So, I'm sure many of you have fight with writing graph data structures in Rust in the past. It's known to be a pain point of the language, but in here I'm using a very common approach, which is just instead of pointers, we can use vectors and use indexes instead of pointers. We can use indexes from it. As I said, the embeddings is just our data set. We have then the neighbor list per embedding, and in there we just store who is the target and the similarity between those. There is one thing that I have not told you about, and we will talk a lot about it, is the entry point to the graph. This is just where every search is going to start. And for now, let's assume it is the first embedding on the dataset. Doing this, We just need to get a query, start at the entry point, and go through the direction of the similarity function till it starts to increase. Seems like we have found the perfect data structure to solve this problem, but not really. Turns out, for big graphs, the entry point we choose may have a bad impact in the quality of our answers, because it may find you a local with what is called a local maximum. It's just something that will stop your search from getting you to the best answer possible. That's a bad problem to have, especially when we expect our graphs to be incredibly big. So, when we found this problem, what we did is go to the research. Maybe academia has found a solution to this. Turns out it has. This paper that I'm showing you here, if you like data structures and algorithms, is a great read. And on it, it describes a data structure that will help you solve the entry point problem. I'm not going to go through all of it, but I invite you all to go through it. We are going to go through the basics. If we were to have this problem and don't have the paper to look at it, one way of solving the problem of the entry point is splitting, having two graphs instead of just one. We may have the nearest neighbor graph that contains all the embeddings in the dataset. This we expect to be a big graph. And then we are having an entry point graph, which contains just a subset of those embeddings. Upon the arrival of a query, we just need to do a first traversal through the entry point graph to find the best entry point for that query and use that as the entry point for the nearest neighbor graph. The data structure described in the paper I just showed you is called an HNSW, and basically what it does is take this idea to scale. This is a visualization of an HNSW, a small one, and in the first graph, which is the one at the bottom, what we have is the nearest neighbor graph. All the embeddings in the dataset are there. Second graph contains just a subset of those. And the third graph contains a subset of the embeddings found in the second one. The higher we go, the less embeddings we found. Doing search in here is just a matter of starting in the highest graph. Doesn't matter which entry point we choose because it's a small graph. As soon as we find the nearest neighbor there, we will use that as an entry point in the next graph. In the second graph, we do exactly the same, and we have found the best entry point for the first graph. And we just do a regular graph traversal that will get us, hopefully, to the best nearest neighbor. Okay? They act as fast lanes for the real nearest neighbor graph. Great, so we have found the perfect data structure for our task. Now we need to do an engineering task of transforming this into something that Nuclia can actually use. And for that, we need to solve a couple of problems. I keep touching it. Sorry. We need to add a couple of filters in the data structure. First of all, Nuclia offers filtered search. This is not described how to do it in the paper, and we need to find a solution for it. We also need to add embeddings to the graph. Need to delete some embeddings from the graph, and we also distribute reads and writes. So let's tackle each one of those. Let's tackle each one of those one at a time. And first we are going to see how we would do filtered search in the HNSW. To understand the problem, let's look at how a naive solution to that problem would work out. As an input to search, we will receive not only the query, we will also receive a set of filters. Filters are just the properties we want our nearest neighbor to have. With that, we go to the whole data set of embeddings and split it into the ones that are filtered out and the ones that are filtered in. We extract the ones that are actually filtered in because those have the properties we are looking for, and from there we build a whole HNSW graph where we will do nearest neighbor search. This explains great the problem, but we cannot afford that search time to build a whole HNSW and do a nearest neighbor search. If we are going to do that, just iterate through all the embeddings at once. What we actually do at Nuclia is, for a brief moment, we will forget about the filters. We'll take the query and we start a regular search in the HNSW. This will get us to the actual nearest neighbor of the query. Once we have that, if we are lucky enough that it is in the filtered in search, it's a lucky day, we just return it. If not, we are at a break point in the graph where we can extract the traversal through following the similarity function until we find an embedding that has the filters. We have avoided building again a whole HNSW, and we are still getting quality results. Great. I told you, we have done Nuclia offers filter research. We have a solution for that. Now, the next two problems that are add new embeddings and delete embeddings are something that is actually a possibility in the HNSW. The HNSW supports addition and deletions, but it's not something you usually want in a search engine. We want our data structures to be as immutable as possible so we can optimize storage for search. So, in order to do so, we were thinking what we could do, and we realized that we don't actually get one embedding or delete one embedding. We have millions no, we have thousands of them per insertion. That's enough embeddings to have a whole new HNSW. And if we think about it, nearest neighbor search is a composable operation. That means that, if we want to do a nearest neighbor search in an HNSW with a new batch of embeddings, we can take this approach where we expand the HNSW and then do a nearest neighbor search in the new HNSW. This requires mutability. We need to load all the HNSW from this, modify it, and store it again. Another thing that we could do is just create a new HNSW from the batch and do a search on it, a search on the old HNSW, and take the maximum. That is also the nearest neighbor. With this in mind, what we actually built in Nuclia is the following system. We have a process that is the writer, and the writer will receive resources. This is batches of unstructured data where knowledge has been extracted, our embeddings and the similarity. From there, we produce several HNSWs, well, one HNSW per resource. These are called segments. And we just store them linearly. And the reader will do the operation we have said of searching in each one of them while keeping the maximum. This, of course, has a problem. Over time, you are going to have millions of segments. It's going to be very inefficient. Our search has become linear in the number of segments. What we do is have another process that will merge from time to time some of these segments, and a garbage collector that will keep the segments that are no longer in use from the system. It's standard in search engine, and since HNSW search composes, works great for us. This also allows us to have immutable HNSWs that are encoded to be optimized for search. As I said, we can memory map those HNSWs, so disk efficiency, so we can access this efficiently, and this approach is very easily distributed. We can send one segment to another process and it will start to use it because it's not going to be modified. One problem left. What happens with deletion? We know how to add new embeddings. We just create a new HNSW, but what happens when one of the embeddings is deleted? We cannot return it anymore. Well, I don't have a slide for that, and it's because we have already solved that problem. It's filtering once again. We just say that one embedding is deleted and we filter it out. So doing filtered search is just filtering out the vision. Okay, that's all about the index, and this is all this code, all these index we built it ourselves, but it would be not fair from me to not tell you about the incredible libraries we use from the Rust community. So I'm going to tell you our shopping list for Grades.io, some of them. FST from Band Sushi. If you are trying to write an index and want to do filtering, I highly recommend you to use this library. We are using it a bit to speed up our filtered search, and it is a great rate, and the code base is amazing. We use TanTV. If you have worked with Lucene at some point, TanTV is what Lucene is to Java. We use it for text search, the search that didn't return the correct answer when we asked peculiarities. Well, for some other, in the cases where that kind of index works, we use TanTV. We use Tonic for building a gRPC server on top of our indexes. We use Pio3 to provide access through Python to our index. And there are many others that I can just not name. We use mmap2 for memory mapping, which is incredibly useful and works great in Rust. So yeah, with that, I can just tell you that all of this that I have talked about is actually part of a bigger project that is called NucliaDB. It's the database we are using for optimizing search for Nuclia, and it's completely open source. You can go to NucliaDB in GitHub and you can find all our code base, including the semantic search index. Find us in LinkedIn. We are constantly putting news about what we do. And also, as I said, visit us in nuclia.com, where you can find lots of resources about it. Thanks.
If anyone has any question or something to Herme, it's the time.
What are the dimensions of the data that you use? What are the dimensions of the data that you use?
Oh, that's maybe a
Trade secret?
No, it's not a secret, but there are many models. It's different dimensions depending on each one.
I was just curious if the dimensions get too big, if this scheme still works or not.
If the dimensions get big, the problem we are going to have is that the similarity function is going to take longer and our storage is going to be bigger. So we are exploring with some techniques on how to deal with that. And yeah, it's a current area of research that is very hot right now. So there are techniques for it.
Okay.
So if you are not deleting embeddings, you at some point you will do housekeeping, or you just let it grow, like storing embeddings until infinite.
No, those are part of. Maybe I can show you. Each segment knows what embeddings are deleted on it. So when when the merger process takes two of them, it will remove the deleted embeddings and create a new one that is clean. It's like tombstone. Thank you.
Yeah, I'm curious about the reason why you choose to build the graph or the search engine from scratch of the semantic search instead of maybe using an already graph database, and they may have several of those things solved.
Thanks for that question, that's great. Well, a graph database for this is going to be very inefficient because of the storage they use, and most of them are adapted to mutability. So that's not a great fit for us, because since we are a search engine. And also, as I said, this is part of a bigger project that is NucliaDB, where it was just a better fit to build one ourselves that would fit better the needs that Nuclia has.
So thank you for the talk. So I am I'm curious about which streaming model are you using when programming in Rust? So are you using like features, so you're doing like flows of information, or you're doing batches, or are you using streams internally?
Well, we actually, the batch of embeddings is related to the data the user has uploaded, and there is a part in the pipeline, which is the AI part, that is in charge of splitting that and streaming it to us via gRPC. So when we get one batch of embeddings, it's all in memory at that point.
Okay.
We can just start computing a new segment.
Yeah, you're doing in batches. No?
Yeah.
Okay.
Thanks for the presentation. Quick question, how do you compare to Pinecone or pgvector or any other vector embedding database that's floating out there? If they're asked because of trust or?
Well, when we started this effort, we did look at a bunch of the open source projects that were in there, and the problem remained the same. Is we need something that is best fitted for NucliaDB and the needs of Nuclia, and that's just what got us to let's build one index ourselves.
Just one question. I don't know if your system is, you are training the models for generating the embeddings.
So sorry, because there is a lot of people here that can answer you that question, but I don't think I can.
You can answer.
Well, at the moment we are not. Well, I think this is a bit out of the scope, but the models that we use for generating the embeddings right now are not training, and we are not training them ourselves, but it's on our pipeline. And we are always choosing like the best models for every use case and so on.
So you mentioned that you use the same library. Is that because you do lexical search as well?
You mean TANDB, right?
Yeah.
Yeah. We also semantic search is good for some queries, but we really think that the best approach for search is when we mix different ones. So we try to run also textual search, regular text search with BN25, and experiment with.
So how do you approach this like hybrid search? Like, what algorithm do you use to like blend the results?
Wow, that's another difficult question. That is an area of research on its own, as I know, but we have people working on it.
The guy is here.
I'm sorry, I cannot answer to that.
Do you want to answer?
Well, again, this is a very hot topic and recent topic, and it doesn't have like a known solution. So right now we have several heuristics that work well in different cases, depending on the data, how dense your data is, how sparse, and yeah, essentially we try to do a ranking between the results of both searches on the different indexes. But yeah, one that seems promising is like the re-ranking problem, which is like giving all these results from both indexes to a model and let the model choose which ones are more relevant. That's something we're experimenting as well.
Is that the reciprocal thing? That there is like something called reciprocal re-ranking function?
Yeah. Okay, thanks.
That's it.
Es como yo.
Ya. Sí, sí. Vamos a ver si sale. Plug and play. Tiene que salir por ahí.
Sí, sí, es el fondo
Es así,
pantalla
tú,
único de...
Depende de la resolución. Está ahora adaptado a la resolución que tengo aquí, entonces sale. Tienes que ponerte... Sí, sí, espera que esté y... Sí, 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 pensaba que lo vería aquí. Sí, sí, no, ahora tengo aquí el otro escritorio. Dos escritorios y un escritorio se me pega.
Well, without further ado, let's give a big round of applause to
Hello.
Hello, can you hear me? Yes. Yes. Sí.
No, no, así no.
Sí, ¿no? Yes.
Ahora,
Yeah.
ahora.
Hello everybody. Thank you for organizing the meetup to the organizers, Roberto and Alberto. I'm going to tell a tale about implementing Storj Rust bindings. So I implemented the high-level bindings. Well, I don't want to explain about that. But that's a Storj, and the other one is Ferris, you know that. Well, Storj, just an introduction, is a decentralized cloud storage. I'm going to talk about the decentralized cloud storage. If you have any interest on it, or you can after come to me, and I can explain you what we do. But mostly we store data in the centralized way, or you can visit the storj.io. A little bit about me. So I am a software engineer working for Storj. That's me in Twitter, GitHub, some other social networks. I think in LinkedIn I have another image. Roberto pulled it from there, I think. Well, not much. I am Ivan Fraixedes, almost everywhere, or everywhere. Sure. A little bit of disclaimer before starting. So this is personal opinions, not the Storj ones. So nothing that I'm going to say here is take it Storj is saying. So you want to blame to me. You want to do whatever. So only from me. We'll see. Well, I actually am software engineer, but not in Rust. So I consider that Rust I am a beginner. So enough with me. Rust languages are, are not, so I forgot the not, are not officially maintained by the Storj. So that means that we have the bindings are in GitHub, but in another GitHub organization about the Storj, but company doesn't have any warranty about them, so it's not maintained. So it should be maintained by a community, and in this case, I think the only one that is maintained now once done, there is not that much maintaining. And if the talk is boring, sorry about that, but you can blame the meetup organizers for accepting my talk. Sorry. A little bit of background. Storj is a Go shop, so there is no Rust. Okay. Yeah, that is, you know. For that reason, I am Rust a beginner, so I do Rust whenever I can. And the bindings are the Libuplink, so that is the client library for connecting to the network. They are written in Go. Another, the C bindings is what we generated as well with Go. So with Go, now yes. But what we are using for creating bindings on top of it is the C bindings. And the C bindings as well are created with Go. Yeah, with Go you can write C. Well, but yeah, you have some Go code, and after you expose it, you can do it with Rust. You have some Rust code that you can expose to C and create some C bindings. It's the same concept, but a little bit worse. First, let's start how we create Rust bindings from C. The convention is to generate the code that maps to the C bindings to a tool that is called Bindgen. Is in the Rust organization, on the Rust Meetup, in the Rust GitHub organization, so I think Rust is maintaining. And basically what you do is this tool take C library, or the C headers plus the binary libraries, and they create a Rust, mostly mapping what is in C to Rust. Everything is unsafe. So you get all the constants, you get all the mostly constants and functions and structs, and the functions are all unsafe. So yeah, I think you do that. Obviously, you have to trust what is doing the C there. And you start and you create what it generates Bindgen. You create a crate that normally you call the name that you want to put to your binding. In this case, it will be Storj. And after dash Cs. That is it. Explain about how it's referencing the headers. And after you create, what you do is you create, obviously you can have that, and that is what the Storj had at some point. And so, yeah, you create that is quite setting up a little bit Bindgen when you build the script, and that's it. So you can start to have those in Rust, but obviously start to prepare to wrap everything in set. And after you want to do a decent job, so you have to take your C's crate and create another crate that is a higher level crate that use the C's crate. So basically, you expose everything without being with nothing safe. Then everybody said, okay. Yeah, another so is what I said. So you map that to being unsafe plus to adapt the API in a Rust, an idiomatic Rust, because the other thing is what C has. One example is the problem is perhaps that I open here the link. No. Not opening because I haven't got one. Tenemos is very difficult. Sorry about that. So this is the Rust OpenSSL, but mostly you can see the OpenSSL Cs, that is the Cs crate, and the OpenSSL is the crate, higher level crate. No. What if I do this, close the one. Sorry because of the inconvenience. 3. Well, now I lost the
try to avoid pressing the. The uplinks is great, have some peculiarities. Well, the uplink C is added as a Git model. So, and after the build RAS compiles the link on C, so that it means that it requires Go. So as I said, so the uplink C is writing in Go, that requires Go, and this is, well, I don't like it, because if you want to use it, even if you want to use the uplink, so like the higher level grade, you have to compile the lower level grade, and that it means that you have to have Go installed in your machine. I opened some discussions to avoid this. So you can have obviously download the libraries, so the binary libraries for the platform that you are compiling. Other solution is putting the libraries in the repository. But yeah, there are trade-offs, you know. But I think you can do some hybrid, having some main platform binaries for say Linux, iOS X, and Windows. And for the where ones, yeah, try to compile. But it is what it is. What it does what the LM6, the Linux is great generated code in this case is an example. But this is what we have in C. And this is what is translated to Rust. So this is what Bcn is doing. So it's taking the struct and convert it to this. So this is Rust. See a lot of pointers there. Yeah, it uses directives that is for, I have to read the other day because this is result generated, so, but mostly to map C word to Rust with memory alignment and all these kind of things. And for a function, you see, so I haven't put here the C function because it's written in Go. That is converted to C, so I couldn't have the C code there. But so mostly it's the same in C, so it doesn't change that much. Only have to change a little bit the names and the types, but it's very close what C has. And here, as you see, so it's this is yeah, it's external C because it's external C. It forces to be in C. Well, we could go. I think it's a present so I think, but maybe try. Put inside. Let's see my mouse. Well, as you know, so .rs generate the documentation for you. But this is what it is. So full of structs, constants, and functions, and all of RMC. And the names are directly translated from C. So it's beautiful. And you have to use this. It's amazing. The link range. That is what that the work that we have to do. So and it's the work that I took to do. So yeah, we have that. Now nobody was going to work in the higher level, and I was interested in working in the higher level. And how I take was. Yeah, I create I started with the link access, that is one of the types that we have, and some base types and helpers to create the first thing. And that I start in a repository in my GitHub user, until at some point so I had a little experimental, and I asked if we could merge everything in the other or in the company repository, and that is when we pass from being a crate to being a workspace with 2 crates and all of that. But those first commits were in my close this. Yeah, it's a little bit tiny. But well, it's got that guide as I said before. But yeah, mostly well, importing the crate, the sys crate, start to create some encryption keys, another object that we have, but obviously this is have to create it because it depends on the other one. Everything has to be implemented, but because the access needed this type, so I left the type empty for implementing later. I create errors packet, errors module to map all the errors that the library could have. This is because I like that the library has errors that I can do something with them. That is nice, the message is nice, but if it's a library, I want the computer to consume the library. That means that I have to know what to do with the errors. Yeah, some errors you will say, okay, I panic, or I close and I work, or whatever, but others perhaps, you know, you can distinguish programmatically which is the error, you can retract. That's an example. So for that, I like to specify error types. Well, implementing, other way, like now, project. And well, I said that I had helpers. These were some helpers because there is a lot of converting things from the C wall to the Rust wall, and that is where C strings and CSTRs are in the game. So mostly here was I needed to compare things from the Rust wall to the C wall, so you have to convert to C strings. And obviously C doesn't like the null character. So yeah, so rather than writing that every better that I had, so you start to think, okay, let's do a function and return the error that I want. So I have always the same message, no typos, because well, typically I would say helper functions. Let's go. I try to follow the best practices about the unsafe code. That is, you have always a unsafe code. You write a safety comment, and you tell why it's not unsafe. But you see, a lot of trust. So, unless that, obviously, what you are calling a C here, yeah, what you can do is when you call something to C, you trust that the C is going to do that. Or yeah, I trust the C bindings. Anyway, so I implemented this ensure method that it's in ensure crate, and I started to implement for types that the uplink is return. I have following. This is, for example, an example of the one of the methods for that on the access type. To get mostly from the access, we get the satellite address and volume safe. So we call the underline sys crate for that. You get the address. That is I think it was a CSTR. You have that is a result that is our Rust map that to from C. It's something that I think that's not correct. So in Go as well, we'll homey map. We return some structs that it can be a field, that it can be an error, or it can be what you want and so on. And that is because we come from Go, and Go you can return multiple values, the functions. So we define the uplink seek, so we map in this way. So mostly what I get the results, you pass the result, and what it does the new uplink, if the error is not nil, then you have the error, otherwise you don't have. rather than checking here, the new uplink that is something that they created in the error module is what it does. So if I told you the error, it's not new. And construct you the error for that, for the proper error. So the error type, in this case, it will be from the uplink type that it has different codes. And this is another safe part of the code. And here is referencing that here this string is not nil because according to the bindings, if error is not nil, this shouldn't be. If error is nil, this shouldn't be nil. So the comment is here is saying, that, okay, at this point we ensure before that error is nil because otherwise we return before. For that reason, this is safe. This is safe. Okay, and when you have. So yeah, you convert that to str. Yeah, you're done. This was to obviously this is a result, and here is that cannot be converted to str. Then I use here we are binding in the message, but that is yeah, because the C bindings are doing something that they shouldn't do. So yeah, I don't know what, that is my approach to do this. What do you do? Otherwise, if the C binding doesn't return you the result that they should return, you have to do something in case it's panicking. The only thing I can do, I don't do just unwrap, so I prefer always to use a spec, at least with a message. Yeah, as I said, there's a lot of trust. Well, in Storj create that again is very simple. So mostly it has a one method. The only what it does is in case it gets itself and check. As I said, this struct has two fields: error and the result. So it checks that if mostly you have to check that if error is not nil. Then, well, the other could be not nil, but if the error is nil, the other half cannot be nil. And in case that doesn't fulfill, then it bindings. So that is because the bindings are not returning the correct error. Yeah, this is one of the implementations for the uplink access result. So yeah, it checks it. The access is not null, and the error is not null. Sorry. Well, the two are null, then something happened. And in case that they are not null, I think in some cases they could be, I don't know here. But anyway, so I think for this case, not. So yeah, they are null, but something is happening, something is wrong. So the base idea of this is identifying that if the bindings are doing something where, okay, let's not develop the bindings and say, hey, there is a bug. And actually working on them, I think I found one. But it was, well, not related with pointers, but it was related with an error that was not mapped. Then it couldn't, the library based on top, they couldn't identify the error. Yeah, this time is the error they said, so the error has this, well, I started with these two kinds, I think there is another one now. But one is for invalid arguments. So I even map the invalid arguments to a kind of type because the consumer has an invalid argument for whatever reason, so he can identify that he's passing something wrong. Mostly probably you are going to exit, but at least with a nicer message. But you could do something else if you want. And the uplink, so the uplink is the errors that the uplink bindings return, because there are some error codes. And at the end, you can identify them if it's an error, connection timeout, and so on. I think this we said before. Yeah, I didn't remember that. I could show the comment, but not the. I had the code here. So. Okay, but this was okay, started to be, but I found some issues and some bugs along the way. Expected. No bugs, so we will have work. First, this is an issue with Docker. This is, so I was documenting everything. I'm a little bit obsessed with that. I wanted to have good documentation, so I was documenting on the way that I was implementing. And at some point, I was presenting a little bit the progress on that in a meeting that we had in the company. I said, no, we're working on this side project. I said, yeah, everything is documented and open. There is no documentation. I said, what? Okay, something is going on that I don't understand. I will check. And I realized that there wasn't documentation for the crate. And the problem was that the uplink sys couldn't be built. And because it couldn't be built in the Docker, system that Docker has used, the other one didn't build, and you end up with documentation for any of them. And the problem was because of Go. So because they use a Docker image, and the Docker image doesn't have Go, so you couldn't compile the uplink sys. And you have two options. I found out that you have two options. So you modify the Docker image and you send a pull request, a frame. I'm afraid because I wasn't expecting these guys were going to add to the image Go because of a crate. I know that that nobody cares. And the other was that you adapt your build. You adapt your build for cheating the WRS or cheating or helping. And there is those two things. Well, you could open it, but one is you detect when DORAS is building your crate, and then you do something different. Part of that you could have some metadata in the cargo.toml for DockerX. In this case, it was taking some of taking the library objects of Linux, putting them in the repository under some folder. And when detecting that the DockerS is building the crate, then you use them. Rather than compiling them, you just keep and just no, use these ones. And then call the bungeon with those ones. And for the metadata, in this case, it was only build this with Linux. Because obviously the objects were only on Linux. You can specify the platform that you want to build. I guess that this is it's good because if you build a crate that only works with Windows, so you turn DockerS only to build for Windows. And we tried to work around, everything started to be nice and see the documentation. But mostly it's what they said. So you detect that it's DockerS, so if it's not DockerS, so it doesn't exist, then you do the normal approach that is calling make in the C bindings. That is what is building the bindings. And in case that one exists, so you copy it. You copy this from this folder, the library objects binaries to the build folder. And that's it. Then I found bugs with C, str, and CString. Yeah, and that it was all my misunderstanding with them. So I think, I don't know how many times I read the documentation of CStr or CString, and I went back and forth with them trying to understand. Yeah, follow me. But this was detected. I had some unit tests, but unit tests worked pretty well and didn't fail because it was static strings. So if the error was present, the pointer didn't disappear. But what happened when I built an end-to-end test or integration test that it used the network? You will spot a network, a local network, and then you can test everything from the higher level. And I started to see problems. And that it was. So I was using wrong here. So mostly I think it was this. Well, this is the things that I had to do to fix this issue. It was in other places, a few of them. That mostly I was thinking, yeah, don't use a string for not copying, just avoid copying, nice, better performance. But yeah, it didn't work because yeah, what happened is you get this CSPR but then you have to release this memory in the bindings with these three. There are some functions for releasing. The C bindings have functions to release, especially the type. And obviously, once they release this pointer pointed to whatever, and obviously after Rust crash. And what you have to do is having a string and make a copy. But obviously you need to mount the copy because you cannot leave the pointer in there because you have to call this, okay, you get the string from there, but if you don't call this, you don't know if this could release other resources that you are not taking. So obviously you could inspect every function and say, oh, it's fine, don't call free, but that's not the point, you know. And moreover, if the C implementation changes, then this is going to break. So you cannot rely on that. So you have to follow the practice that they say that you have to. Yeah, and after I had to do some work around it. So I tried to get better images. I didn't know how well going to be projected here. In my script, projected quite well. Not in the screen, my phone screen. That's another thing. But anyway, so the workaround here with the read implementation was that the network, when you download the data, you read the data as a reader. But at some point it returns zero length. But it doesn't mean that you finish. So you can call it again and you can get the data. And for Rust, when you have to get zero length, that ends. So here I have to do, let's do, okay, you get zero length, try it again. Okay, let's give it for 3 times. I don't expect that more than 3 times is going to be returned 0. And that is how I solved the issue. Because otherwise I couldn't download all the data. So my test was complaining that the data doesn't match. Yeah, but that's perhaps of the behavior of the C bindings, how you map them to the last word. Here I don't remember what they put. I think it was the same. So that's what it said. This is part of the changes, I guess. Yeah, this is what it was before doing. Yeah, I remember it was the red one. Yes, didn't fit in the same screen. So they said first I was downloading, yeah, and was taking that and returning. The byte that it was read, but I said when web 0, the iterator said, okay, I'm done. So, and he ended up doing this retry 3 times in case that is 0. So try it again and you get some data. Okay, good, you return that, and so the iterator continue. Obviously at the end you get 3 times 0, so okay, the iterator finished. But with the test, I think it was fine. So. And then, yeah, so I'm going to explain a little bit my obsessions. After this, when everybody tell you after this, go to the therapist. This is what it is. I said, I talk about the errors, so I really like, so I came into the documentation. Okay. We are going to see the mouse. I'm going to see the mouse. Is it ready? Putting the mouse. Hello? Fine. Yeah, as I said, so now there is another one that is the internal error. Internal error is something that I detect inside that it shouldn't happen, and it's when you want to avoid, but you know, if you get an internal error compared to anything, just avoid and tell me that, yeah. Well, I said you cannot continue. One of the things when I use sometimes the spec,
I starting prefixing those messages with bug, telling that if you get this, tell me that there is a bug. So it's not your fault. Well, this implemented error, but mostly has this uplink perhaps more interesting either. I know that there is these libraries that can do all of this, but perhaps, yeah, coming from, I wanted to implement my errors rather than rely on libraries for learning purposes, I guess. I did a few times in implementations. The other thing, the other ones never finished. And I worked those things to here. And I was reading a blog post at the end, okay, you can do with the library, you can do it as well. So it depends if you want to have a dependency or not, so I wanted to avoid the dependency. It was not too bad to do that. So, well, I said here is mapping all the codes. So you have the internal, cancel, all those codes to many requests are coming from the network. So nothing fancy. Okay. Yeah, test. Yes, that helps a lot. Could be more? Sure. Yeah, it could be more. I think it's quite well tested. Unit test, I struggle a little bit what can I test with unit test for these things. I have some. And the end-to-end test is, I would say that is checking everything, but obviously it could be more cases, I guess. But yes, so I don't know when that ends. Document. Yeah, this is the thing stuff. I like to document the things, so I really don't really like, with no blaming to anybody that is releasing things in open source, that is very welcome. But I don't really like that there is no documentation, because it's difficult to use. If you want to contribute, it's difficult to contribute. And obviously I complain about, they should always have documentation. So, yeah, I wanted to talk about this. So, even I had the documentation for the code, for the grade. I also have the documentation of decisions that I made. How is I would say the design or the architecture of the grade. I talk about the errors. I talk about some naming conventions that I use for when getting things, when converting things from Rust to the C, or to the higher level, or to the admin C. Let's call that C. And if you use from, as, and so on. And everything was documented. And I wanted to document this, but I didn't want to have a web page for documenting this. And what you do is mostly you create a module. It was not my invention, I took from somewhere. The only thing is I couldn't remember the blog post where I read first that. I couldn't find what the other day. But after I see in other places that they use the same, but you create a module that is called docs, and after you create, so you create the docs module, and after you create other modules, and there are two here, that one is the design and the other is the Storj. The Storj is mostly a copy-paste what we have in the uplink library for Go. It explains what's the network, how the network works, so that is mostly copy-paste and adapt a little bit for Rust, for examples, because the other examples for Go. But it has the same documentation. And the design is where I'm explaining the decisions and the conventions that I took and I would like to follow. That was as well for me an exercise to have homogenize the implementation, because at some point I was okay, so call us from what, and actually when I wrote this, and after I had to go back to the code to make sure, and I had to make changes because okay, I didn't follow my conventions, so that helped to be a little bit to be more everything homogenic. Well, and this is what you do. So mostly in that module is everything commented, and that's it. So you comment that, and Docker.rs make the work to for example, that one, complicated thing. Let's go on. Maybe compared to this, so not maybe how we were writing at the top of your file, but this file doesn't have any code. Everything is the computation. Commit messages, yeah, that's another important thing for me. I follow conventional messages, conventional commits, sorry. Well, yes, you never read, so explain a little bit the structure that you have to do. But obviously, when I brought this code to the admin sys that was created initially, though they didn't use any convention. And I started that everything that the commit that they wrote that wrote in these commit conventions, even they are not committed in the repository as something that you have to follow. But there is an issue created there that mostly I created by myself, trying to somebody that is in the company that started with the admin sys, but that is not much organization anyway. But mostly just open example, not the conventions itself, but I guess, I don't know, perhaps I don't need all them. Because mostly because I'm struggling with number. Where is it? So it was in the white thing. I am blind. So now I have to do over. Well, you should try to, well, the convention is about the prefix, but for me important is the message there explaining what you are doing there. This is another thing that I miss from some projects, trying to understand what is that commit doing. Obviously, it's very minimal, not needed, but anyway, it's an obsession. Now what? Now I close what I did. Just to do. Yes. What I'm planning on communication is, I think that you see that in other repositories. So people start to create a project and put some checkboxes to achieve things that they are doing. So I did that because I wanted to see my progress, to see what I am doing, that is the plan that I have. We can change a little bit, but I can't tell people what is my progress. This took me quite a bit of time to implement everything, and it was for me. But I like it because people can see what the stage is the project. Once I finish everything, so I remove. That's it. But at the time, so it was no, doesn't go. Yes. Well, any question? Short. Any question? Shoot. Yeah. Well, credits to Storj for the logo and the Innovation Day program. That is where I work on this, so we can work in projects that mostly almost everything is accepted. After you speak with your manager, 15% of the time that they are not in their own plan, I decided to work on that. Yeah, the color restrictions for the graph is public domain. I didn't want to start to, if I can put the Rust logo, yes I can, for at least, but anyway, so with that it was easy, and Ivan Elber is one of my mates, my colleagues, and the buffer I was taken from him that he draws buffers with me, many other things, but I was looking for buffers and at the end I ended up going to his repository to take the buffer that you see, so this is the credits. Questions, any questions? Before that, you get bored, yeah, we have time. Pizzas are not here, so it's fine. All right. Here? Well, anything is happening.
No, there's not here.
Okay, good. We can talk about, so there is no problem. Pizzas are going to be warm. Any question?
you were talking about how we split the trait into the one with sys and the main trait, and that this is a pattern that some other projects are using. Can you explain more for us that are not so well versed in what the best practices are?
I believe that is the best practice. I haven't read that the practice is there, but I don't remember where I read that is. I think I read in there is some book as well related to bindings. I think from Bingen actually. The Bingen book tells you about that, but after I started to look for projects, relevant projects like OpenSSL. When I see OpenSSL 750, this is one that I can use as a guide. And yeah, I see. And the convention is you use Bingen to create your lower level conversion from C to Rust. You call that create the name that you want to go to your create -sys. And after is the other create, you put the name that you want, and basically you add a dependency, the sys create, and you create a higher level. So idiomatic API for the create. Anybody else? Any more questions? I think we are good to go. Okay, thank you.
Cuidado con pizzas.